We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
Good morning friends. Today we are going to solve the problem of triangle plane. Okay, let's see the question. In question given that a 30 degree and 60 degree set square has its shorter edge foot long. Okay, here one set square is given and here a set square. So 30 degree and 60 degree set square means all 3 angles are given. One angle is 30 degree, second is 60 degree, and third one is 90 degree. Okay, its shorter edges and is in HP. So here I write on first stage for HP, second stage for theta, and third stage for phi. The top view of the set square is an isosceles triangle. So condition for the top view is given. This set square is seen as a isosceles triangle in top view. Okay, draw the projection with the hypotenuse of set square. Hypotenuse of set square inclined at 35 degree to the VP. Okay, means phi is equal to 35 degree. Okay, and it's made by the hypotenuse of the set square. Okay, now here the theta is not given for the second stage. Okay, but one condition is given that the top view of the set square is seen as an isosceles triangle. Okay, so first I draw one reference line at here. Okay, here plane is resting on HP. Okay, so we draw the set square on horizontal plane and it is resting on shorter side. So we draw the shorter side on left hand. So I draw the shorter side at here. I giving the name A, B. Okay, now I draw one perpendicular line to the side AB. Okay, because it's a set square, so I draw one perpendicular line at here. Okay, this angle is 90 degree. Okay, now here we don't know the length of the longest side. Okay, here in question length of the shortest side is given. AB is equal to 44 mm. Okay, but length of the longest side is not given. Okay, but if we draw the set square, okay, this shortest side. Okay, so we know that the hypotenuse makes an angle 60 degree with the shorter side. Here we know the length of the shorter side. Okay, so we draw the hypotenuse at angle of 60 degree. Okay, so here I measure the angle 60 degree and draw one line okay, which intersect this perpendicular line at here. Okay, so here I get my point C. Okay, so after joining B and C, I get the top view for the first stage. Okay, now for drawing the front view, I just simply take the projection. So here I get my point A dash, B dash, and at here I get my point C dash. Okay, here A dash point is hidden point. So after joining A dash C dash, I get my front view. Okay, so in this way I complete the first stage. Okay, if I measure the length of BC, then length is equal to 77 mm. Okay, so in second stage theta is not given. Okay, here in second stage theta is not given, but one condition is given that the top view of the plane is seen as a isosceles triangle. Okay, so in second stage we draw the set square of two equal sides. Okay, here the length 44 mm is constant. Length of side BC is reduced to 44 mm. Okay, because in second stage the set square is seen as a isosceles triangle. Okay, so we draw the isosceles with two equal sides of 44 mm. Length of this 77 mm side is reduced to 44 mm because of inclination. Okay, so first here I draw the projection for point A and at here. So here I get my point A and I draw one line at here. Okay, length of this line is 44 mm. So here I get my point B. Okay, now we need to draw the isosceles triangle. So from point B I measure the distance of 44 mm. Okay, so here I get my point C. Okay, so after joining A and C, I get my top view for the second stage. Okay, I explain again. Here in second stage angle theta is not given, but one condition is given that this set square is seen as a isosceles triangle. Okay, so here in second stage we need to draw the isosceles triangle. Okay, the length of AB is constant in second stage. Okay, here length of AB is constant. Okay, this length BC is reduced to 44 mm side due to the inclination. Okay, so here I first I draw side AB. Okay, and then from point B I measure the 44 mm distance and I mark the point C at here. Okay, so after joining A and C I get my isosceles triangle in top view. Okay, now for getting the front view I take the projection from here and from here. Okay, here the plane is resting on side AB. Okay, so here I take the point A dash B dash. Now for point C I have two conditions. Okay, that the point C I get on this projection line. Okay, and distance of point C dash from the point A dash is equal to this much. A dash C dash 77 mm. Okay, so I take A dash C dash as a radius. Okay, and A dash as a center. I draw one arc which intersected here. So here I get my point C dash. Okay, so here I get my front view. Okay, and if I measure this angle, then this angle theta is equal to 55 degree. Okay, theta is equal to 55 degree. Okay, so in this way I complete the second stage. Okay, now let's come to the third stage. In third stage, given that the hypotenuse makes an angle 35 degree with the vertical plane. Okay, so first I check that the length of hypotenuse is constant or not in both cases. Okay, so here we clearly seen that the length of AC hypotenuse is changed in both cases. Okay, so in this case we require to find the apparent angle. Okay, because length of AC is changing both stages. Okay, here angle 35 is given for this length. Okay, but in second stage the length of AC is reduced. Okay, so we require to find a new apparent angle for this length. Okay, okay, so for that first here I take the point A. Okay, and I draw one line at angle of 35 degree at here from point A. Okay, this angle is 35 degree. Okay, now I measure this length AC in first stage. Okay, because 35 angle is given for this length. Now I take A as the center and draw one arc which intersected here. So here I get my point C1. Now from point C1 I draw one line parallel at here. So this line give me the locus for point C. I get my C point on this line. Okay, now I measure the length of AC in second stage. Okay, because we require to find a new angle for this length. Okay, now I take A as a center, okay, and draw one arc which intersected here. So here I get my final point C. Okay, now I connect A and C. Okay, and if I measure this angle is our new apparent angle. Okay, so here angle beta is equal to 55 degree. Okay, so here we get the apparent angle beta is equal to 55 degree. So now we draw the hypotenuse AC at angle of 55 degree. Okay, so first I draw one line at angle of 55 degree at here, because hypotenuse makes an angle of 55 degree. This angle is 55 degree. Now I take AC as a radius. Okay, I mark point A at here. Okay, now take A as a center and AC as a radius. I draw one arc at here. So here I get my point C. Okay, now I take the AB as a radius. This length is 44 mm. Okay, now I take A as a center and draw one arc at here. Now I take C as a center and draw one arc at here. Okay, so here I get my point B. So after joining AB, BC and AC, I get my top view for the third stage. Okay, now for drawing the front view, I take the projection. First I start with point A. I take the projection for point A from here and from here. So here I get my point A dash. Okay, now for point B, I take the projection from here and from here. So here I get my point B dash. Now for point C dash, I take the projection from here and from here. So here I get my point C dash. Okay, so after joining A dash, B dash, B dash, C dash, and C dash, A dash. Okay, I get my front view for the third stage. Okay, so before ending, I just checked that the side on which plane is resting is always on reference line or not. Okay, here plane is resting on side AB. Okay, so here in first stage, point A dash and B dash are on reference line. In second stage, point A dash and B dash are on reference line. In third stage, point A dash and B dash are on reference line. Okay, so here I complete this problem. Okay, here in this problem we require to find the new apparent angle beta. Okay, because the length of AC is changing both stage. Okay, so here I conclude this lecture. Thank you.